Great, I'll kick us off. Welcome everybody to our first iSchool colloquium of the spring semester. Our speaker today is Katharina von der Wense. She is a, excuse me, an assistant professor of computer science at University of Colorado Boulder and a junior professor of the Johannes Gutenberg University in Mainz, Germany. She leads the VDW Natural Language Processing Group. She received her PhD from LMU Munich in 2019 and was a postdoc at NYU until she moved to Boulder in 2020. Her work is centered around deep learning for NLP with a special focus on multilingual NLP and transfer learning, computational morphology, language grounding, and NLP for medical and educational applications. Katharina, thank you so much for joining us today. So I'll just kick it over to you.
Thank you so much. Hi, everyone. Thanks for inviting me. Can we do a quick round of who has which background? So can everybody give a thumbs up who has an NLP background? 2, 3, 4, 5.
What does that mean?
It means has worked with NLP in some capacity. Okay, so like 6-ish. Okay, yeah, I kind of expected not everyone to be like a core NLP person. Okay, let me also make the Zoom smaller. Okay, so yeah, so my talk is going to be about AmericasNLI and the search for a path towards universal natural language processing, which is kind of my main, I'd say, research area, my main research interest. So for those who don't have an NLP background, a very quick slide on what NLP actually is. So the goal of NLP is to build machines that can do useful things with human language. And of course, what exactly is useful, kind of like up for debate. But somehow we want to build machines that can handle human language in some capacity. So the natural language processing actually just means human language as opposed to programming language. And I think most of you have seen some sort of NLP system, but there are way more tasks or way more systems than just ChatGPT. So one task you might also have seen is machine translation. So here, the idea is to do translation in an automatic way. For example, here between English and Japanese. Another task you might be familiar with is question answering. So here, the input is a question and maybe some additional information, and then the output is, as the name is saying, the answer to that question. And then there are also a couple of tasks people might not know if they don't usually work with natural language processing. So for example, here we have part of speech tagging, semantic tagging, dependency relation tagging. So there are some lower level tasks as well. Yeah, and obviously the most popular one is probably like dialogue generation. I prepared this slide for my comprehensive review. So I asked ChatGPT, how can I pass my comprehensive review? And yeah, it gave me an answer. I don't know how good it is, but it's an answer that sounds somehow reasonable. And yeah, so what I'm mostly going to focus on is that natural language processing currently is pretty much English centered, and maybe not only English centered, but it's centered a lot around so-called high resource languages. So languages that have a lot of resources, mostly digital resources, that can be used to build systems. So the most, I'd say, popular language in NLP is probably English. And then I'd say maybe Chinese, German is pretty well represented, maybe Spanish. And then there are a couple of languages that have like decent amounts of data, but the large majority of languages actually have no, or basically no useful data for natural language processing at all. And this results in settings we call low resource settings. So you can basically not train the systems that you would train for English for those languages just because you don't have the data. And the same is true for other reasons. So we have also tasks for which it's very difficult to collect data, especially tasks that require like certain skills to make that data. Could be translation, could be something more linguistic-y. Like, I think not many of us can just write down dependency parsers. And then another reason why data might be limited is the domain. So for example, for the medical domain, like imagine you want to build a system that can read in like a patient's symptoms, so patient describing, I'm not feeling well because I'm feeling X, Y, Z, and then gives you a hypothesis for what the disease might be. You cannot like just tell people like, okay, I'm going to pay you, $20 an hour, sit down and describe some symptoms, because it just doesn't make sense. So for some domains, it's really difficult to get enough data. Yeah, so in my work, I'm interested in kind of all those reasons, general low resource settings, but I'm mostly interested in settings with low resource languages. And yeah, this situation, like not having NLP for all languages, has a couple of negative consequences. Some might be rather obvious, some might be less obvious. So for example, speakers of low resource languages don't have access to information, for example, on the web. So, I mean, we all speak English, so it's very easy for us to open Wikipedia or just use Google, find answers to questions we might be interested in, maybe ask ChatGPT. Now, people who don't speak English and don't speak any other high resource language can do the same thing, right? So if they want to look for something, they need to either like somehow figure out how to translate, they need to look within like books in their language. So the situation is totally different. In addition, by not having, for example, machine translation systems, it is difficult to communicate with speakers of low resource languages, for example, in emergency situations, but just also, in general. And then one less obvious negative consequence is that also since systems such as maybe ChatGPT, Google Translate, Siri, Alexa only work for high resource languages, endangered languages and dialects are used less and less, both because while using those systems, you can't actually use, let's say, the dialect you would usually speak, but then also the fact that those systems don't work for your dialect or like your language might lead to a more negative perception of the dialect or language. And then you just kind of could feel like, okay, it's a bad thing to like speak it. So maybe you just by yourself speak it less because you feel kind of like bad about it. Okay, so the goal of my work is what I call universal NLP. And the idea of universal NLP is to build systems that work for all languages and for all tasks in all languages. So also including like all domains, etc. Of course, that's like super ambitious. So I'm not sure if, we're going to reach this within my lifetime, hopefully. And I'm definitely not going to like reach this on my own. And there are lots of people who are interested in this, but I really think like this is a worthy goal to pursue. And in order to reach universal NLP, we need a couple of different, like, let's say, sub-goals. One is the development of data sets and data collection approaches. One is to build linguistic resources for low resource languages. Another one is to build models for high-level NLP tasks in low resource languages. And then there are also like two kind of meta goals. One is the education of students and researchers in approaches suitable for low resource NLP. And one is to increase the involvement of the NLP community and speakers of low resource languages in work towards universal NLP. So yeah, I've done a couple of things to try to get the community involved. So organized a couple of workshops, shared tasks, which is kind of like what we call competitions. And one of those is especially important because what I'm going to talk about today is coming out of the workshop on NLP for Indigenous languages of the Americas. So overall, we could say that today we're mostly focusing on how to build models for high-level NLP tasks in low-resource languages, and because it's closely connected, this workshop as well. And as I'm going to talk a little bit about this workshop, I'm going to start with some advertisement. The goal of Americas NLP is overall to encourage research on NLP, computational linguistics, corpus linguistics, and speech around the globe to work on Native American languages. And another goal is to connect researchers and professionals from underrepresented communities and native speakers of endangered languages with the machine learning and natural language processing communities. And the last one is to promote research on both neural and non-neural machine learning approaches suitable for low resource languages. And yeah, so my collaborators and I co-founded AmericasNLI, say maybe around 2020. And then the first workshop happened in 2021. Our goal was, so actually what we thought was, so since NACL that year, so one of the big NLP conferences was supposed to happen in Mexico City, it would be really nice to have this like workshop on indigenous languages of the Americas, because Mexico has lots of indigenous languages. But then, of course, COVID happened, so the workshop happened. It did not happen in Mexico City. And then, yeah, it was followed by NeurIPS competition in 2022, a workshop at ACL in 2023. And importantly, this year, we're actually going to have Americas NLP in Mexico City. Yeah, so finally in Mexico City. And yeah, if you want to participate or you're interested in maybe just attending, yeah, you can check out the website, but the submission deadline for papers would be 10th of March, and there will be 2 competitions, one on machine translation and one on the generation of educational material for indigenous languages. Okay, now for the first part of the talk, we're going to move away from Americas NLP, and then we get back to it later on. So as we want to build systems for ideally all languages, in 2021, my PhD student, Abtin Ibrahimi, and I asked the question, how can we adapt a pre-trained multilingual model to 1,600 languages? Why 1,600? We're going to see that later on as well, but basically right now, multilingual models have very limited language coverage, maybe up to like around 100. And we thought, okay, if we take a larger resource, the Bible, we can extend this to like by a factor of 16 to 1,600, which is roughly a fourth of all languages on Earth. So yeah, it would be a huge improvement. So the question is kind of like, how can we do that? How can we take pre-trained models, make them applicable to that many more languages? In our experiments, we mostly looked at XLMR, which was kind of like the state-of-the-art multilingual model at the time. So model, okay, a transformer encoder model that has been trained on masked language modeling in 100 languages. And yeah, at the time, it was basically the best model out there. Now you would maybe look at Bloom or something similar. But importantly, most languages are not actually represented in the training data. So over 6,000 languages are ignored by this model, especially endangered languages or dialects. So yeah, we kind of wanted to know, how can we change the situation? And there exist a couple of approaches that are useful for taking pre-trained models and then making them applicable to additional languages that are not contained in pre-training. So one of those is called Extend from Wang et al. 2020. And the idea of this is to extend the vocabulary of a model to then include subwords that are important for the new language. This would especially help if the languages, or the new language is very different from the pre-training languages, or also maybe if they use different scripts. So you basically take the embedding matrix, you add a couple of new rows for the vocabulary items that are specific to the new language. And then you train the overall model on target language raw text. So let's say you want to adapt to Wirrárica, you would take a model, you figure out, okay, which vocabulary items are important for Virarica, add them to the embedding matrix, and then you train on Virarica like text without any annotations. Then another strategy that exists and that we also tried is called adapters, Pfeiffer et al. 2020. And here the idea is to add specific layers, so new layers to an existing model, and then to train those new layers called adapters on target language raw text. So similar to what you did for extend with the kind of like with the vocabulary, just that there you also trained the overall model, while for adapters you would only train the specific part. Then another adaptation approach that's pretty common is continued masked language modeling pre-training. So you do what the model had been doing during pre-training, but you continue with that on text from your target language. And then something else that has been tried is continued pre-training on translation language modeling, which is basically the same as continued masked language modeling pre-training, but now instead of using just text in your target language, you use parallel text between your target language and one of the languages that are already used during pre-training. So the idea is that the model can take information from one language to predict words in the other language. So it's kind of like a mixture of masked language modeling and translation. So if you look at this, the important part is that all of those methods, so extend, adapters, continued masked language modeling pre-training, continued pre-training on translation language modeling, somehow use target language text. And target language text is, well, relatively easy to come by compared to other resources, but it's still difficult for low resource languages. So what we wanted to see was, how does this work if we don't have, like, let's say, reasonably huge amounts of raw text? And all those previous works assumed that raw text was basically an unlimited resource, which we don't think is realistic for actual low resource languages. So as I said, we thought about which resource is actually widely available. And we settled on the Bible because it is the largest published data set in NLP right now. At the time, it covered 1,611 languages. I think it's still work in progress. So right now it might be a couple more. But yeah, that's when we did the research. And yeah, we used that to explore model adaptation. So we wanted to see how well do the previous methods work if we only use the Bible. Yeah, and this is to give you an idea of the scale. So these are all low resource languages, but still the Wikipedias are like way larger than the Bible. I think those are token counts, separated by white space, so very simple counting. So yeah, we really thought, okay, not everything that works with Wikipedia is also necessarily going to work with the Bible. In fact, when we started with this project, we expected this to work pretty poorly. So we it's kind of like one of those things where you want to show, okay, if you actually look at a realistic setting, it doesn't work at all. Yeah, that was kind of how we started this. And the other problem we saw was that Wikipedia and the Bible are very different. So we've talked about domains before, but yeah, so here's actually a domain problem as well. So for many tasks, you would expect text to be more similar to what you find in Wikipedia than to what you find in the Bible. And yeah, we tried 2 target tasks. One was named entity recognition. So the goal of named entity recognition is to recognize named entities in text. So for example, if the sentence is Barack Obama is a politician, you want to, let's say, recognize, find Barack and Obama, the 2 words that make up this name. And here you can already see why we would expect domain to be a problem. So it's very unlikely that Barack Obama shows up in the Bible. It is, however, very likely that Barack Obama shows up in Wikipedia. So if you train the model, or if you like adapt the model using Wikipedia, you would expect it to have knowledge of like common names that potentially show up in your task data as well. If you train it on the Bible, maybe not so much. Then the second task we experimented with was part of speech tagging. And here the idea is to assign syntactic categories to words in a sentence. So again, if we look at Barack Obama as a politician, then I mean, it's kind of simplified, but we would expect to have like noun, noun, verb, determiner, and noun. As you might have noticed, both of those are very like low-level tasks. So they're very different from things like machine translation, dialogue generation, maybe question answering. They require limited understanding of semantics. And this is not because we thought, okay, we absolutely don't care about higher level tasks. In fact, like in the beginning, right, I said like number 3 is to build NLP systems for higher level tasks. But it's just that we were interested in low resource languages. And since they are low resource languages, it was actually impossible to find suitable data for, let's say, like more interesting tasks, maybe. Yeah, here are the languages we used and the tasks. And maybe most importantly, you can already see that only for very few of those languages, we had both tasks available. So for most, we have either named entity recognition or part of speech tagging. Then I think only for 3, yeah, we had both tasks. So this really shows like, or this kind of like, you know, it's a good example of this low resource problem. Okay, here are the results that we got exploring all the different strategies. This is for part of speech tagging. So the very left one, XLMR, is kind of our baseline model. So this is if you take the pre-trained model that works for 100 languages, you don't do anything and you just apply it to like your new unseen language. And then the second one is taking this model, doing masked language modeling on the target language, and then well, okay, applying is like training on English and then applying the model. The third one is using translation language modeling for adaptation, then extend, and then adapters. And yeah, you can see mostly actually 2 things here. Like the first thing that we didn't expect was that adaptation actually worked for all methods, even though we only used the Bible. So in the best case, we got like an 18% improvement, which is actually quite a lot. I mean, like 54 is not like an amazing performance. Part of speech taggers for English perform at like high 90s, but still, it's like, it's much better than 36, 37. And the second thing that we saw that was kind of surprising was that the like more advanced methods, so extend and adapters, actually worked worse than the simpler methods, just using masked language modeling, translation language modeling. I mean, we thought it was probably because extend and adapters are more like, let's say, complicated. So they require adding new parameters to the model that then need to be trained. So the problem of not having enough text is probably more severe here. But still, it's kind of like a cool result because it means that you can just do the easiest strategy. Like it's very straightforward. And it actually, first of all, helps. And second, it even helps better than more complicated approaches. And here are the results for named entity recognition, F1 score, still the same approaches. And here you can see like a similar picture in terms of we do see improvement. The improvement is smaller though, so from 43 to like 49-ish. And also we don't see improvement for all methods. So extend and adapters actually perform worse than our baseline. So it's kind of like, okay, the same as in it still helps, but it's, yeah, it's kind of different in terms of ranking, in terms of overall, like how much it actually helps, how effective it is. And we assume this is because of the named entity recognition domain problem. So it's, yeah, probably more severe here where you would really care about having seen the names at some point. But then for part of speech tagging where like words is still kind of like, you know, similar between the Bible and maybe your test data, but yeah, names might not be. Okay, so the conclusion of this first research paper was that we can indeed use something as limited, both in terms of domain and size, as the Bible for model adaptation. We also found that masked language modeling works better in this setting than other more complicated approaches. And translation language modeling works best for named entity recognition, but it requires either the Bible or some other parallel text so that you actually have the translations you need for this. So, and now we actually come back to AmericasNLI because now we wanted to see how well does this work for a more complicated task. So we used a new data set that we made in the context of that workshop, AmericasNLI, for evaluating zero-shot natural language understanding of pre-trained multilingual models in truly low-resource languages. So yeah, this is a very complicated to understand title, but the idea is basically, can models do higher level tasks for unseen languages if we adapt them with a small amount of data? Okay, so as I said, the motivation of this work was that named entity recognition and part of speech tagging are both in a kind of low-level tasks that don't require much understanding of meaning at all. And this, I mean, of course, means that it might be different from tasks that do require more understanding of meaning. But it also, in like practical terms, means that translating the test data and applying an English system is not straightforward. So like a translate test approach. So you can think of this as assuming you want to do, let's say, sentiment analysis. So take a sentence, like let's say a tweet or a product review, and you want to say if this text is positive or negative. So it expresses like a good feeling or bad feeling about something. So if you want to do this for a low resource language, one option would be you take this tweet and you translate it into English, and then you just use an English system to say, okay, what is the feeling expressed in this tweet? And this would work because ideally, if your translation system works reasonably well, the sentiment wouldn't change when switching to another language. Now for like named entity recognition, part of speech tagging, and it's maybe not the same because for part of speech tagging, also named entity recognition, but like part of speech tagging, you would assign like one thing to each word. And then if you translate, the words change. It's like, it's kind of not like this whole translate test approach is easier if you can just take the meaning and like convert it into another language. Yeah, and the same is true for translating the training data. So you could also imagine, assuming you still want to classify your tweets, you could take English training data for the task, translate it into your low resource language, then use that new data set to train a system and then apply it to your tweets in your low resource language. And yeah, as I said, the main reason why we used named entity recognition and part of speech tagging was that finding data for like higher level tasks in low resource languages is not that easy. So we created this new data set called AmericasNLI that originally came to be as, I guess, so it was, okay, we like kind of thought about how can we somehow combine two things. So we wanted to do machine translation chat task in the AmericasNLI workshop. And we also wanted to explore the question we're asking here. So we said we can do this by building a system for a task, a data set for a task by translating an existing data set. So we have kind of two things in one. We have the translation. We also have the data set for the other task. And the task we chose was natural language inference. That's why it's NLI. And the task basically consists of predicting the relationship between two sentences, so the premise and the hypothesis. And usually for this like version of the task, there are three options. So one is entailment, one is contradiction, and one is neutral, which is basically no relationship between the two. And here in this example, a cat sat on the mat entails an animal sat on the mat, because whenever the sentence a cat sat on the mat is true, then because a cat is an animal, the sentence an animal sat on the mat is also true. We decided to make an extension of a data set that already was multilingual. So the data set called XNLI from Kono et al. 2018. And this data set was already an extension. So it was an extension of SNLI and MNLI, which are kind of the most popular natural language inference data sets. And as I said, because we built a translation, or we basically translated, this data set is also suitable for machine translation evaluation. The data set covers 10 languages. They're all spoken kind of like in like southern, northern, central, South America. People have asked us, why is there no language from the US? That wasn't intentional. It just kind of happened because of the collaborators we had. But we would be happy to also include other languages. Yeah, so importantly, maybe two things. But AmericasNLI only has development and test sets, but we also decided on a couple of domains. So there are different domains in there. For some domains, our translators said that it didn't make sense to translate into indigenous languages because many words were like kind of uncommon. So yeah, we kind of picked a little bit based on this. And then also, even though the task is based on pairs of sentences, our translators all translated individual sentences. So this is kind of a shortcoming because sometimes you can translate the same word in different ways, and then maybe the relationship changes. We knew that, but we decided to keep it that way because the same was done for AmericasNLI, and we kind of wanted it to be similar. Okay, so yeah, so the models we tried. We checked the performance of zero-shot learning. So the idea here is you take the pre-trained multilingual model and then you fine-tune either on English NLI or Spanish NLI, well, or any other, but like we tried English and Spanish. And we did that for the base XLMR model and for XLMR with continued pre-training, which was the best method we found in the previous project. So we said, okay, we try the best method now. But now, because of the nature of the task, we also tried MT-based approaches, namely translate train and translate test. So as I said, translate train is you take your training data, you translate it into the indigenous language, you train your model, and then you apply it as usual to your test set. And translate test is kind of the opposite. So you have a model that's trained in, we used Spanish, and then you translate your test examples into Spanish and apply your model to those examples. And maybe that's obvious, but those approaches require external machine translation training sets. And of course, not only training sets, but also the respective models trained on those training sets. Yeah, here are the results that we got. So we have the zero-shot approaches with and without adaptation. So again, our question is, how well does adaptation work, right? So it's kind of like that difference. And then translate train and translate test, which we expected to be trivial baselines. And you can look at the last column that shows the average performance, and that kind of reflects pretty well what's going on. So we can see that the base model, so just taking XLMR, which has not been trained on any indigenous language, and applying it to indigenous languages, gets pretty bad performance. So 38.17, 38.62, so basically the same. And you also need to keep in mind that natural language inference is a like three-way classification, and the data is pretty equally distributed. So if you randomly guess, you would get like 33%, right? So 38 is not that much better than just random guessing. In fact, I'd say it's probably not worth the effort. They probably just like guess. And then we do see an improvement using adaptation. So we didn't use the Bible, but we still used a pretty small data set. So again, this was kind of surprising, from 38 to around 44% accuracy. But then the really surprising part is that translate train actually obtains nearly a 49% accuracy. Translate tests like roughly as expected. So better than the non-adapted model, worse than the adapted model. But yeah, so we looked at this and we're like, okay, it's nice. So adaptation still works. but really what is happening here with this translate train performance. And of course, you could say, well, you just build a system in like the language you were interested in. So of course, it does somehow perform well. But the weird part is that our translation systems were actually really, really bad. So let me quickly talk about what we used. So we had a transformer sequence-to-sequence model with hyperparameters that are suitable for small training set sizes. So mostly it was a pretty small model. It was trained on external training sets that we had collected also for the AmericasNLI workshop. But there were a couple of challenges because the training sets were from sources that were unrelated to XNLI or in like kind of because of this, the AmericasNLI dataset. So for example, they sometimes used a different orthography. There were tokenization differences, domain differences, etc. And this resulted in actually pretty poor models. So here are the scores from Spanish to the indigenous language and indigenous language to Spanish. They're just two different scores, so character n-gram F score and probably they're probably both the kind of like very common MT metrics. Blue, but yeah, those scores are really, really, really low. So a blue of like, I don't know, 0.3, 3.2. That's basically ridiculously low. Like I would expect this to not look at all like the actual language. And in fact, we looked at a couple of examples. I don't think I have them. Yeah, I don't have them here, but they're in the appendix of the paper. And the examples were really something like, so it absolutely did not make sense at all. Some made sense, of course, right? It was like some point in what happened, but most of them looked pretty terrible. So we were really surprised that even though translation worked that poorly, we still got better results with that than with our adapted pre-trained model. Yeah, so the conclusion of this second part is that pre-trained multilingual models perform above chance level on natural language inference, even for unseen languages. However, performance is poor. Remember, like 38 compared to 33 random guessing. So yeah, like really poor actually. Adaptation via continued pre-training does improve performance by like 6 points, but the best performance is obtained by a translate train model, and this is happening even though the translation performance is pretty poor. So yeah, like kind of from that, but also in general, just from recent developments, talking to other people, the question with which I want to end this talk is kind of like, okay, moving forward, like what is actually the most promising strategy to reach universal NLP, especially in the context of building NLP systems for high-level tasks, like let's say NLI, dialogue, question answering, machine translation maybe. So do we rather want to focus on cross-lingual transfer via multilingual models, like kind of like this multilingual model pre-training zero-shot approach? Or does it actually make more sense to move on to machine translation, say, hey, this is actually solving all our problems? And right now, the field is very much focused on building those multilingual models. And mostly machine translation is kind of treated as like what we wanted to do for AmericasNLI, kind of like a simple baseline that's anyways going to be outperformed. Yeah, so multilingual models versus machine translation. So a question we could ask is, do we even need multilingual models at all? Like, what do they give us if we could as well just translate? So does this mean that MT is all you need? Or maybe not? And yeah, I found a paper recently, a couple of weeks ago on arXiv, Ebing and Glavash, that says perfect machine translation, MT would render cross-lingual transfer, XLT, by means of multilingual language model superfluous. And yeah, I've discussed this with a couple of people, and maybe I think the statement might be too ambitious. So one thing people could think about is even assuming that MT outperforms or MT-based approaches outperform multilingual language models. Maybe you can build multilingual language models that are more efficient, maybe use fewer parameters than machine translation, etc. So there are different aspects to this, but just from a performance perspective, yes, if we had perfect machine translation, we would not need multilingual language models because we could just, translate, solve the task in English. Why would we even bother like building models for specific languages, except for the machine translation model? So let's look at the side of MT. So why is MT better than cross-lingual transfer via multilingual models? So obviously MT has a wider utility. So with the multilingual models, if you say we have XLMR, you would probably say, well, okay, we have XLMR, but what do I do with this XLMR? I think everybody understands why MT is useful, right? Like you might translate text if you're traveling. You might translate things while talking to people who don't speak your language. I think nobody would doubt that building MT models is a useful goal in itself. Yeah, so we need MT anyways, so we could as well build good MT systems, use those for cross-lingual transfer instead of other, like maybe less obviously useful approaches. Yeah, as I said, we don't really need multilingual models for themselves. Then, yeah, maybe MT is even better because the performance is better. So for AmericasNLI, we have seen that the performance is in fact better than multilingual models. And also the other paper I've cited, the 2023 paper, showed that you can do a couple of tricks, improve your MT system, and then often outperform multilingual models if you don't just like, naively do translate, train, translate, test. Yeah, so MT already works better now, and perfect MT would work perfectly for many tasks. Not all tasks, but at least something like NLI would be solved with perfect MT. A question that I believe is currently unanswered is, can cross-lingual transfer via multilingual models be perfect? So the intuition I have is that those multilingual models kind of like loosely align words and sentences, so they kind of match up, and then they kind of get the same performance as you would get with the original language. But can they actually be like exact enough to ever get to like the original accuracy? So let's say you train a model in English, then you do zero shot for another language. Can you get to the English performance with a multilingual model? I don't think I'm certain nobody has answered this. And it's obviously very hard to answer a question, but I'm not even sure if people have thought about it enough. And importantly, also many times multilingual models aren't even compared to MT. So many times people publish papers, they say, okay, we have this improvement for pre-trained multilingual models, zero-shot cross-lingual transfer, but then they don't compare to translate, train, translate, test just because they assume it's like a worse baseline. So yeah, the question I kind of want to throw out there is, do we think we want cross-lingual transfer when what we actually want is perfect machine translation? So like really, is NLP as a field maybe, I don't want to say working on the wrong things, but like maybe putting too much effort into some things and ignoring other things too much? So what you could say is surely not, or else why would so many people be working on cross-lingual transfer with multilingual models? But I mean, that's not a very scientific answer. There are lots of reasons why people could work on something if something else was actually better. So yeah, I published an entire paper about this with colleagues in 2021. So for example, people work on legacy research questions that are motivated by problems or tools that are no longer relevant. Examples from my own work would be something like we do this morphological pre-processing because it has been shown that it's useful for, I don't know, let's say machine translation, question answering. And that's true, so it's not a lie, but it has been shown at times when systems worked way worse than they work nowadays. So it's kind of like people take motivations that were true at some point, but are not true anymore, and just like copy them over basically. People could also work on projects because they think those projects maximize short-term gains for the researchers. So there might be quick research questions, might be easy to take a pre-trained multilingual, figuring out how to build MT systems. For low resource languages might be either difficult, very time consuming because you need to build the respective data sets, etc. So it might just be faster to, I don't know, jump on this train of like pre-trained multilingual models. However, we could also say, okay, maybe multilingual models are actually better for some tasks. So maybe MT isn't actually all we need. So you could think about tasks for which multilingual models might be the only reasonable options. For example, word segmentation. So if you are given a text and you're supposed to like split it into individual words. For English, usually you can just like split on white spaces, but for some languages you can't. So here, I don't really see how you would translate and then split and then translate back. And so, you know, it just doesn't make sense because it's not really like meaning based. So there are definitely tasks for which multilingual models are still kind of useful. Spelling correction as well. So assuming you have a misspelled text in a language, it wouldn't really make sense to translate that into English, correct the spelling there, and then translate back. So you could think of like workarounds. So you could have something like a misspelled text, you translate into English, you get normal English, you translate back, and then you just compare the two versions or something. But that would require having an MT system that can handle the original misspelled text as well. And it's just not very straightforward. Yeah, and then other tasks for which multilingual models are maybe not the only option, but more straightforward, like part of speech tagging named entity recognition from our first project. Again, there are strategies how you could use baselines based on MT, but they're not, yeah, like they're not the easiest. They involve like alignment and stuff. So yeah, not straightforward. However, there's also, or maybe not however, like in addition, there's also MT itself. So even if you say, okay, maybe what we want is really perfect MT for all languages, then how do we even reach this perfect MT? So maybe we need multilingual models in order to improve MT for low resource languages, reduce the amount of training data required for low resource languages. So I think my own personal conclusion is kind of like that multilingual models are really beneficial for MT, like kind of like as a means to the like end of building perfect MT systems. For many other approaches, I'm not that sure, but yeah, I basically want to leave this a little bit open. Okay, so yeah, this is the end of this part and also the overall end of the talk. So MT often outperforms multilingual models, and perfect MT will likely outperform multilingual models on all suitable tasks, unless we can also get perfect cross-lingual transfer via multilingual models, which I don't see right now. I might be proven wrong, but I personally don't believe it. Importantly, MT-based approaches are often ignored in papers on cross-lingual transfer. So this might make you believe that pre-trained multilingual models are the state of the art when they're actually not. I mean, there might be, but if you don't compare, you don't know. So this is a suboptimal situation. And yeah, but then there are other tasks, so which like cross-lingual transfer via multilingual models is likely actually the better choice. So it's like, yeah, like both sides. And importantly, multilingual models are useful for machine translation. So yeah, so kind of I want to leave you with a couple of take-home questions. So thinking about what is the path towards universal NLP that's the most promising. So which tasks are multilingual models better suited for than machine translation? For example, machine translation itself, spelling correction, etc. For which tasks can or should one rely on machine translation? For example, sentiment analysis. Then maybe more for linguistic people, can MT be perfect in practice? The other interesting question is really, what would we need for perfect MT? And another thought I had is like, do we need to be quick? As in like, are we going to lose the option to collect what we need if we wait too long, too many languages go extinct, etc.? And of course, can cross-lingual transfer via multilingual models be perfect or not? And if it could be or can be perfect, what do we need for this? And does it align with what we're currently doing? Or is what we're currently doing with the multilingual models basically a path towards a kind of like dead end at some sort of performance? Okay, and that's it. So yeah, I'm actually done. Thank you very much for listening. And yeah, I'm happy to take questions or discuss a little bit.
Great,
Thank you so much, Dr. Katharina. I didn't mean to disturb you at all. I'm so happy to have a lecture with you. It was very informative, and I did try NLP once. It was very amazing. Thank you
What
so
did you
much.
do with NLP?
I had like I sat on a chair, and it was a different NLP. It was neuro-linguistic performance.
Okay. Nice.
Yeah, it's a different one. But it's pretty amazing to have you at our university. Welcome to Arizona.
Thanks.
Okay.
Great, thank you. We have a couple questions in the Q&A window. Can you see those, Katharina, or do you want me to pick one and read it out loud? Or the askers of those questions can also just raise their hand and ask them directly. So Steve and Sarah, basically, would either of you like to ask your question out loud, or do you want me to just pick one and read it?
Sure, I can ask my question out loud.
Great, thank you.
So I want to know why on earth such terrible machine translation helped the Indigenous language NLI, right? So what kind of things did the translate train models that were trained with terrible translations get right that like the just mass language modeling models got wrong, right? What were they fixing? Because I'm just having a hard time imagining what you could fix if what you train on was, as you described it,
No. That was the output. That was not the training. The training was better. It was just not enough data for training. But I mean, it's also
But you use the output when you train the NLI model, right? Because you translate and then you use that terrible output as the training for the NLI.
Okay, so first of all, I don't have a clear answer because we thought about analyzing it more, but then we didn't speak the language, so it's like very difficult. Two hypotheses, like one would be that some words are still translated correctly, maybe negations, etc. They might help. And then also because it's NLI, right? And we know that there are a lot of like artifacts in the data. So could be that it was also partially about the length of the translation, partially about like some other things in there. So we aren't totally sure. What I know is that if you get better MT system, performance goes up because they tried it in the 2023 paper. But yeah, so no clear answer, sadly, but we wanted to have one for years.
I have another question, but I think we should let the other questions go first. So you can come back to me later.
Yeah, Sarah, do you want to ask one of yours?
Sure. Yeah, this is a very perhaps a basic question, but very selfish too. So I'm working on a named entity recognition project, and in the talk you said it's a sort of a low-level task. So I was curious if that is in like some contexts but not others. Maybe you could elaborate a bit on, maybe an NER, is it like it's an easy task if you have an exhaustive dictionary and there are a few named named entities that are emerging, like on TikTok, I imagine like named entities of like expressions of surprise, if there's like new hashtags or something. Sick, man, I don't know, might be like a harder task. So I was curious if like in the context that you looked at, this was a low level task. And for those of us who are working on it, could you give us any tips for named entities? I'm looking at software and scientific research papers, so.
So I mean, low level is maybe a bad description because it makes it seem like super easy, but that's kind of not, I mean, it's not what I mean with this. It's kind of, I think it is easier than certain other tasks like translation, because in like an easy case, you can just do string matching, right? But obviously not in all cases. I think what we mostly want to say is that you don't need to understand the entire meaning of the entire like sentence or text in order to like detect the named entities. And that's kind of all. But no, and that maybe it's usually used as a pre-processing task. So I kind of, you know, in the terms of a pipeline, it would be like the lower level thing.
100%.
But yeah, I don't want to say that in all situations it's super easy. I don't think so.
So we can get a grant if we try to do this. No, just kidding.
Yes. Yes, you can.
Thank you. Thanks.
Thank you.
Remo, why don't you go ahead?
Yeah, sure. Yeah, thanks for the talk, Katharina. I have sort of a couple of thoughts, and I'm wondering generally about this this pursuit of sort of an universal NLP. If your aim is to let's say support low resource language communities, using these kinds of approaches that really require large models, that require a lot of data, I wonder if perhaps have you considered going the other route and just saying, okay, because we have these really low resource languages, we need to have most likely specialized approaches, maybe more classical ML approaches that require less data, perhaps don't get this amazing accuracy we get out of large language models, but can do really well with less data. I've been struggling with with these kinds of problems because I'm working with some quite low resource languages at the moment as well. And for one of them, we did have a multilingual model. So this was a Romansh language in Switzerland, which is a tiny minority language family here. And we did have a pre-trained BERT model that was trained on a dialect of this language we were looking at. And for the type of data that was sort of naturalistic, conversational data, it really wasn't better than just character-informed conditional random fields, which turned out to actually perform much better. So I think if you have these low data situations, I understand like the impulse to go for large models because they're really useful if you have the data to train them. But I'm wondering sort of, aren't you going to just hit a wall by the fact that these languages are low resource languages, and that's kind of the entire point of that classification. So until they become non-low resource languages, maybe we need to work on specialized models and sort of low data solutions. I don't know.
No, I totally agree. Like, I think it's a valid criticism to say, like, why would, like, especially in our work here, why do we only look at large neural models? I think the question is like, which approach would scale better, right? So it's a similar like one versus the other as with MT. Yeah. So for the specialized models, like sometimes you need to put like in additional like knowledge you have about the language, right? So assuming you have no people who have that knowledge, like would you actually be able to get that? Then do the same models work for all languages, or would you need to put in like time to basically build models for all languages, and then maybe after you figured out which models to use, you don't have people anymore to like actually build the like data you need, or it's like kind of, I don't know, then the multilingual like pre-trained models can do zero shot as well, so maybe you don't need data for all tasks. So yeah, one thought I have is like, if you want to build models for all tasks in all languages, right? So creating data sets for all tasks in all languages, just like new tasks show up all the time, right? So you would never stop. So if you have a perfect MT system, you basically just stop and maybe translate, right? And then for the specialized models, kind of the same thought. So yeah, I don't know. I think it's, yes, I think you in many cases, you can probably right now get better performance using specialized models and putting in additional knowledge as well. If it's a like solid solution for the future and for all languages, I don't know. Could be, maybe, but I right now I'd say maybe no.
Thank you.
But very, very interesting question for sure. Thank you.
We are out of time, but we do have one more question in the chat if you're willing to spend another couple minutes. Ames, do you want to ask your question? or I can try to read it. You're muted. Ames, you're muted.
Great. I'm not very good at language myself. Yeah, if we don't have enough time, it's fine. But I was just curious.
No, it's fine.
Okay. Yeah, I also, and this is like from a place of total ignorance on the idea of like a universal NLP, but it was just making me think of communities who don't consider reading the question, consider the particularity or inaccessibility of their language to outsiders as endangerment, but the distillation of their community or the communication into data for unmediated access to researchers in transnational markets is often considered the danger to their survival, which I think can be really reflected in the language itself of like targets. So earlier you said like a lot of these researchers are connecting with communities whose language is considered in danger. And so I'm wondering how they're responding to that, if when and if they're coming across it, and if they're affirming the agency and autonomy of those who are either expressing that or just not expressing anything in either way.
So the question is basically, should you just take data from a language no matter what and build your NLP systems, or is that a kind of bad idea, right?
Yeah, and maybe not even take language from the data, but like turn that language into data itself.
Mm-hmm. Yeah, no, I think it's totally a valid concern. So a couple of maybe 1 or 2 years ago, there was a paper that said Indigenous communities are very excited about having NLP systems for their languages. And I know that's not just universally true. So I kind of was like, okay, that's too bold of a statement in a sense. So I totally believe that if communities don't want to have NLP technology, they don't want their language maybe to be understood, they don't want their language to become data that should be respected. I think the main point in my head is that we should be able to do it, as in we should know how to do it for languages that want to have NLP systems. But that doesn't mean that we then have to use whatever technology we have for all languages, and we probably shouldn't do that.
Okay.
But yeah, also a very good question.
I think the universal aspect, I think I was just misunderstanding. Thank you. That's really helpful.
No, thank you.
Thank you so much for joining us today. That was a really interesting talk. And thank you to everybody else for coming and joining us and asking such good questions. Yeah, so thanks.
Thank you so much.